Students, now welcome to the video number 5. Today I am going to discuss in this video the construction of the Nicol prism and what are the uses of the Nicol prism, and next one is the production and the detection of the plane polarized light. If it is possible, I will go to discuss circularly polarized light and also elliptically polarized light. Here, this prism was constructed by the Nicol. Name of the scientist is what? William Nicol. William Nicol. In the year 1828, he constructed this image. This prism he constructed by using what? Calcite crystal. By using a calcite crystal. Calcite crystal is a double refracting crystal. It is a double refracting crystal. Sometimes it is called as a ice spar. It is called as ice spar here. As I explained in the previous class also, in the previous video also, the calcite crystal is a double refracting crystal, so that whenever the light is incident on it, ordinary light, there are two rays are produced, two refracted rays are produced. One is ordinary and another one is what? Extraordinary ray, and all that explained. Here, this is the rhombohedral structure, hexagonal rhombohedral structure. Like this is the rhombohedral structure. It has got 6 faces. Yes. Next, I will join it. This face, this one. So that it is face number 3. Next, this is what? This part is there, no? It is 1. This one. This is 2. That is second face. This is second face. Second surface I will call it. It is 2. This is what? 3. Next, I will join it. This one I will join it. This one I will join it. This is what? 4th surface. This is the 4th surface. You would have asked question, which is 5th and 6th? Students, you see, this surface is there. No, it is here, one. This surface. This is the what? One surface. It is called as a 5th surface, you can call it as. Next, similarly, this one is what? 6th surface is there. And here the 3 corners are meeting at this point. One is this axis, this axis, this. This is called as an what? Blunt corner. It is called as blunt corner. It is called as blunt corner. Next. In the blunt corner, what is the beauty of this blunt corner is? Angle between any 2 axes, this axis, it is what? 109. Angle between these 2 is what? 109 degree. Angle between this is what? 109 degree. Now, any line, that is what? It is an imaginary line. It is a direction. Now it is passing through it. This line. It is called as optic axis. It is called as optic axis. It is a direction. And I can draw any parallel lines, I can draw it. This also optic axis. This also what? Optic axis. I already explained in the previous videos. What is optic axis? What is the beauty of optic axis? Along the optic axis, velocity for ordinary ray and velocity for the what? Extraordinary ray, both are what? Same, and all that I explained. Okay. Now let us come to this one. Construction of the Nicol prism and all that. Here you see, students, one more. This side is there. No? Here, this, what is the angle here? 109 degree. This is the angle is what? 109 degree. And this angle is what? 71 degree. It is together, it should become 180, that's all. It should become what? 180 and all that. This is 71 degree and this is what? 109 degree. Now I am taking the one face of it, I am taking here, one part of it, one face I am taking. See how I am constructing this. If you read the book directly, you will not understand anything else. Now I am constructing slopes. This is the rhombohedral hexagonal structure at 2 degrees. Okay. Remember, slopes. Always the length is 3 times the more than the breadth is. Length is more it is. Length is more. This is the length. Like this. This is the what? Breadth. This length is, if it is 30 centimeter, this is what? 10 centimeter. This angle is 109 degree. This angle is what? 71 degree. This is one face and it is what? It is another face. What Nicol is did is, he cut the faces of this face and this face. This face and these two are opposite face. Or else I can cut these two opposite faces, he cut here. And also it is what? Polished. How he cut is, he increased this angle is there. Now he made it what? 68 degree, that is. Now I will draw the angle. Now the crystal is cut in such a fashion, it is, earlier it is how much it is? 71 degrees there. Now I will cut it like this. When I cut it like this angle, it becomes what? 68 degrees students. Earlier it is how much it is? It is 71 degree. Now it becomes how much? 68 degree. But totally I said that it should be what? 180 degree it should become. So that this should be increased by 3 degree. It is what? 1, 1, 2 degree. It is 1, 1, 2 degree. Similarly, this face is also what? Like this. This is also, it becomes 1, 1, 2 degree. Always in this rhombohedral hexagonal structure, the opposite sides are always equal. Opposite sides are always equal. If it is 71 degree, this also what? 71 degree. If this is 109 degree, this also what? 109 degree. And the angle between these two adjacent sides should be equal to what? 180 degree and all that. Now, this is the part of it. Here is taking this part is. Now I will remove this part, I will remove it. Now, this part I will remove it, and this part I will remove it. This is what Nicol prism is. This is what Nicol prism. It is not completed. Next, what he will do is, he will cut. Diagonally, he will cut it. Like this, he will cut it. Like separate. He will diagonally, he will cut it. After cutting, again he will paste it by using what? One Canada balsam layer. You see, cut it and then what? Paste it by using what? This layer. It is called as a Canada balsam layer. It is called as a Canada balsam layer. Canada balsam layer. It is an adhesive material. It's just like a gum, that is. Why is cut only by 68 degree? 68 degree because its angle is changed from 71 degree to what? 68 degree. And this 109 degree, it is changes to what? 112. This is what? 68 degree. Here you see, this is perpendicular. This is what? Perpendicular. Here. Now, why he cut made it for only 60 degree? Why not 69 degree? Why not what? 43 degree? I will tell you later. And this Canada balsam layer is there. Now there is one particular type of adhesive material and all that. Remember, students, the refractive index of the Canada balsam layer, it lies between ordinary and extraordinary ray here. It is a 1 minute. Here NO equal refractive index of what? It is ordinary. It is 1.658. Refractive index of emergence ray is equal to 1.468. Refractive index of what? Canada balsam equal to what? 1.55, that is. See the beauty of it. The refractive index of this Canada balsam layer, it lies between the refractive index of ordinary and refractive index of what? Emergent ray. Now the question is, of course, students are not asking the question, that is, they have no habit. Why he is converted 71 degree to what? 68 degrees. Why reduce only by what? 3 degree. That I will tell you next in 2-3 minutes. I will tell you this in the next discussion. I will tell you that. Okay. Now this is the what? Canada balsam layer. This is 68 degree and this one is, I told you that is, it is 112 degree and all that. Now it is unpolarized light is incident on this. Unpolarized light. This is the unpolarized light. Why it is called unpolarized light? It has vibrations in all different planes and all that. Here, the moment the light enters into this, it is obtained. One is what? E ray, and another one is what? It is called as an O ray. Two refracted rays are produced here. One is what? Extraordinary ray. This one I will draw the normal to it. This is the normal drawn to it. This is called as an angle of incidence. Angle of incidence. Angle between the incident ray and this normal is called as in what? Angle of incidence. This is the normal. This is the what? Refracted ray. This angle I will call it as a what? R1 it is. I will call it as a R1 it is. What is R1? R1 is the angle between normal and what? Ordinary ray. Next, this angle I will call it as a what? R2. What is R2? Angle between emergent ray and what? This normal is called as a what? That is angle of refraction here. Look into this diagram. R2 is greater than what? R1 here. R2 is greater than R1. What is R1 here? R1 is the angle between this angle. Angle between ordinary ray and what? Normal. What is R2? R2 is the angle between emergent, E ray and what? Normal. From the geometry, you see R2 is greater than what? R1 and all that. Next. Here, what is the difference between the extraordinary and this one is, in case of extraordinary, the vibrations are like this. Vibrations are like this. In a direction parallel to the optic axis. Parallel to the optic axis. Whereas these vibrations, in case of ordinary, where the electric component is what? It is perpendicular to the this one. It is perpendicular to the optic axis. This is the difference between ordinary and extraordinary. Here, how the light is vibrates in a direction of what? Perpendicular to the what? Optic axis. But here, in this case, the light rays vibrates in the direction of what? In the direction parallel to the what? Optic axis and all that. Now we will ask a question, why this ordinary ray is traveled like this here? This is called as normal angle. Here, this ray suffers from the total internal reflection. Now, listen carefully to this. It suffers from the what? Total internal reflection. What is the condition for the total internal reflection is, light must travel, condition 1, light must travel from denser to what? Denser to rarer medium. Light must travel from denser to rarer medium. Second one is, you know that if the angle of incidence is greater than the critical angle, it is greater than the critical angle. Light undergo or light suffers from what? Total internal reflection. What is the critical angle? Critical angle. And we know the formula for the critical angle. The critical angle sin C equal to, recall that equation, what is written in the PU secondary and all that. Refractive index of rarer media divided by refractive index of what? Denser medium. Now the question is, which is rarer medium and which is denser medium? Now I will connect this one. Canada balsam, and also you are talking about which ray here? Ordinary ray. For ordinary ray, the refractive index is so much here. And for the Canada balsam, that is what? This one. You see? Which is more here? This is more here. So that it is one part. So that this is denser medium and this is what? Rarer medium. Because light is traveling from denser to what? Rarer medium. Now I will calculate sin C. Now this will be, if I calculate, now rub it. The sin C equal to sin of C equal to refractive index of rarer. Rarer is what? N of what? C. Refractive index of denser, it is what? NO equal to, substitute this, it is 1.55 divided by 1.658. Then you calculate yourself and then calculate the value of C. This C is nearly equal to 68 degree. That is 68 degree. But from this geometry, this angle of incidence here, it is more than the what? 68 degree. It is more than this because this is the normal. It is an incident ray and this is the what? Normal. So that definitely this ray, it will undergo what? Total internal reflection. But you would ask question, why not for the emergent ray? For the emergent ray, you see, NE, not emergent ray, E ray. For E ray, it is 1.468. Emergent ray is E ray. And here it is NC equal to 1.55. Here, this is rarer and this is what? Denser medium. So that it will not satisfy the condition of what? Total internal reflection. The condition is satisfied only for which ray here? Ordinary ray here. Not for the what? Extraordinary ray. So that by doing all these circles and all that, what you learn from this is here, whatever this ray is that, that is mixed component is that now, it is completely, it is filtered. Ordinary rays completely, it is eliminated. The outcoming ray is only, it has got vibrations only in one direction. Only one direction. But here the vibrations are what? Here, like this. And another one is what? Perpendicular to the what? Both. Here, one set of rays, one set of vibrations are completely eliminated and outgoing ray is completely, it is what? Plane polarized. It is what? Plane polarized light here. That means the Nicol prism is used to produce the what? Plane polarized light. What is the conclusion here? The conclusion is the Nicol prism, important point. Nicol prism is used. Nicol prism is used to produce the plane polarized light. How you produce here? Here one set of vibrations, whatever the O ray is there now, it is vibrating in one direction here, perpendicular to the plane of the board or something, optics. This ray is completely, it is what? Eliminated here. By what phenomenon? total internal reflection here. The conceptual based question they may ask you this. Why there is Nicol prism, there is what Canada balsam is used? Because this refractive index of the Canada balsam is lies between ordinary ray and what? Extraordinary ray here. The Canada balsam acts as a what? It is an adhesive material and all that. Second point is what? Why cut only to the 68 degree? Because for this mechanism. Because where is we know that already told you that is critical angle. How much critical angle you are getting? C equal to what? For this I am getting 68 degree. That's why he modified the calcite crystal by cutting this. Not only in this year, students, by cutting this prism now like this by 3 degree and all that, the field of view or the field of observation is also what? Increases here. Okay. Students, now I am going to discuss another part of this, production and detection of the plane polarized light, or sometimes it is called as linearly polarized light also. Production of the plane polarized light and also what? Detection, whether the outcoming light is it plane polarized or not, that I want to what? Identify it. Okay. For this I am taking the two prisms I am taking, Nicol prisms I am using. One is, it is prism 1, I will call it as a what? Polarizer. It is called as polarizer. This is called as analyzer. Analyzer means to detect, to identify. Here you see, this is the unpolarized light. It is unpolarized light. And already told you this crystal is modified form of what? Calcite crystal. Earlier it was 71 degree. Now it is changes to what? How much it is? 68 degree. This is also what? 68 degree. But this is 112, 112. I told you in the previous video that is. Okay. This is also 68 degree. This also 68 degree. Now you see, the moment the light enters here, two rays are obtained, I said that. Two rays are obtained. And this ray will be what? Eliminated. This is called as O ray and all that. I told you that just now. In the O ray, how it is? The vibrations are perpendicular to the principal section of the prism. How the vibrations are? Perpendicular to the what? Principal section of the prism. But this ray here, of course, space is less. Vibrations, how the vibrations are? These vibrations are parallel to the what? Principal section. This is called as, it is extraordinary ray and all that. It is called as an extraordinary ray and. Just now explain all these things here. This O ray is completely eliminated. Only one set of plane polarized light you are getting here. That's why you call it the what? Polarizer. The polarizer is the one which produces the, or by which we can obtain only one set of vibrations, that is in one particular direction. It is what? How the vibrations are parallel to the principal section of the prism here. Next, this light I will pass it through the second prism. I will pass it. Second prism. This is called as a E ray. How the vibrations are like this only. Vibrations are like this, parallel. When the vibrations are parallel to the principal section here, this intensity here, observer is here. I can't draw the diagram. Observer is here. You rotate the Nicol prism like this. You rotate it. You rotate it. Clockwise you rotate it. In the previous video, that is video number 1 and all that I told you, when the principal section of this prism and principal section of this prism, which is this? This is polarizer. And this is what? Analyzer. When both are parallel here, then what happens? The intensity is I is maximum. I is maximum. You go on rotate it. As you rotate here, the principal section of this will become what? Like this. Next, like this. Next, like this. Next, like this. This is the angle. Theta will be this theta 1, theta 2, theta 3, like that. This theta will be what? Decreases here. Now, when this is polarizer and analyzer, both are perpendicular. Both are perpendicular. Theta equal to what? 90 degree. At the time, intensity is minimum. Intensity is minimum. Intensity minimum means I equal to what? 0 here. Should be very careful about it. The intensity becomes what? 0. When they are become equal here, the principal section of this polarizer and analyzer, both are how they are? Perpendicular. That is. Here one more equation is there. Here it is intensity is given by I2 equal to, this is the intensity I1. This is the outgoing intensity is what? I2. Here I2 equal to I1. I2 equal to I1 into what? Cos square theta. Analyze this equation. Theta, it is the various, the continuously which is varies here, this angle is varies. Because you are rotating the what? Analyzer. As you go on rotating, initially both are what? How they are? This one and this one. Principal sections, both how they are? Parallel here. When they are parallel, theta equal to what it is? 0 degree. What is cos of 0? Cos of 0 equal to what? 1. Then I2 equal to what? I. Whatever the intensity is there, here the same intensity you are getting. So that initially it is what it is? Maximum. It is maximum. Now, principal section of this is gone changes like this. You are rotating like this. As you rotate like this angle, you see, this angle, this angle, this angle will be gone what? Changes here. Once it becomes principal section of the polarizer and principal section of the analyzer, both becomes 90 degree, theta equal to what? 90 degree. When theta equal to 90 degree, then cos of 90 equal to what? 0. Substitute this, I2 equal to what? 0. This is a minimum. This is minimum. Minimum. The minimum means how much it is? I equal to what? 0. This is how one should write about the production and detection of the plane polarized light. Very simple writing. Draw this diagram here. Let us consider an unpolarized light is incident on the what? Polarizer. As a result, two refracted rays are obtained. One is a E ray and another one is what? O ray. It is extraordinary ray and this is what? Ordinary ray here. This ordinary ray, it undergo what? Total internal reflection. By the mechanism of total internal reflection, the O ray is completely eliminated. Only the emergent ray is what? E ray. This ray is allowed to pass through the what? Another Nicol prism that is called as a what? Analyzer. That is. Now, go on rotate the what? Analyzer, you can rotate it. In one complete rotation, what happens is 2 times the maximum and 2 times the minimum intensity. Minimum means equal to what? 0 is obtained. When it is maximum, the maximum is obtained when the principal section of this prism and the principal section of this prism both are what? Parallel. The minimum is obtained when the principal section of this polarizer and the principal section of the analyzer both how they are perpendicular. If you are observing 2 times the maxima and 2 times the minima in one complete rotation, then I can say that it is a plane polarized light. Incident light is what? Plane polarized or not. That I can identify it. I don't know what is the incoming light. Whether is it plane polarized or is it circularly polarized or is it what? Unpolarized or is it partially polarized or is it elliptically polarized. That I can identify using this mechanism. That is. Okay. Now I will stop it. In the next video, I will going to discuss the production of the circularly polarized light and also what? Elliptically polarized light. I will discuss it.